Are you feeling curious? Today on Curious Crew,
Mine is so slimy.
we'll get gloppy with gloop,
It's huge.
grow giant gummy bears,
We have to bring out the diapers.
and dissect diapers?
They're like long molecular chains.
We're exploring polymers.
Oh,
Got
it
really
looks
sick
cool.
really fast.
It's a polymer party.
Amazing. Hi, I'm Rob Stevenson, and this is
Curious Crew!
That's right. Welcome to the show. We always like to start every episode with a couple of discrepant events because discrepant events stimulate.
Curiosity!
That's right, puzzling phenomena that make us start to wonder. Well, I've got a couple of interesting ones for you here. You guys have ever heard of the shell game where you hide something under the shells and you move it around? You guys heard those? Okay, we're gonna do something silly with a shell game. It's only not with shells, it's with styrofoam cups. And we're going to try to keep track of water. Okay, so I've got 40 milliliters of water, and Lily, you're gonna help me out. Notice carefully, I'm pouring it into this cup. She's got to remember where the water is. Do you think she can do it? As I carefully move these around. Oh my gosh, where's the water? Where's the water? Where's the water, Lily?
Right there.
Okay, so clearly she's good at this game. Okay, we're gonna try one more time. Where's the water? Where's the water? Where's the water? Okay, gosh, I'm so sorry. I thought for sure I had this worked out. Where is it now?
Right there.
Okay, man, I can't do this. Okay, that was, you didn't think that was very good? All right. Okay, where is it now? See, I was trying to be really tricky that time. Where is it? Where is it?
Right there.
She thinks it's there. She thinks it's there. She thinks it's there.
Wait, what?
Okay, wait a minute. Okay, that is kind of interesting. Okay, let's just set that aside. We'll come back to that in just a second. I have something else here. Put that over there. And I've got a little drill. We've got something called polyvinyl alcohol in here. Sasha, you're gonna help me out. I'm gonna drill this really slowly with a glass rod, and you're gonna describe to me what you see.
It's like going onto the rod.
It's going on to the rod. It's climbing up on top of the rod. How can it climb up on top of the rod? That's kind of strange. I'm putting that in there, I'm just drilling it, and it's climbing up on top of the rod. Okay, discrepant event over there, discrepant event over here. This is a little puzzling, don't you think? Yeah. Any wonderings here? Wonderings? Matthew, wondering?
What happened to that water?
That is a really good wondering. This is one of those amazing phenomena that you can actually pull it at a party or something. It's a trick. What do these things have in common? What do you think we're going to be discussing in today's episode? Matthew, what do you think?
Maybe like water molecules, atoms?
Water molecules, atoms, good. So this does have to do with molecules, actually very special molecules. And in fact, my tie is an example of a kind of these molecules. The key word we're going to talk about is something called polymers. Really interesting. Stick around, we have a lot to explore, and we'll come back and explain how these two interesting discrepant events work. Should be fun.
Did you know that polymers are all around us? It's true. In fact, anything made of plastic is a kind of polymer. But so are the proteins in hair, fingernails, or a shell of a tortoise. A few other examples of polymers include cellulose in paper, rubber, and a really fun example, silly putty. But what do they all have in common? If we could look at them through powerful microscopes, we would see that the molecules are like long repeating chains bonded together. This structure makes it possible for polymers to behave in very interesting ways.
Wasn't that cool with that disappearing water, you guys? Okay, we need to explain this a little bit. Polymers are really long molecules. Link my arm for just 1 second there. Link on, link on. If we were to link on together like this, they're like long molecular chains. But something strange about these polymers is they'll behave in unusual ways. Now, I've got a couple of gummy bears here. You guys ever eat gummy bears?
Yeah.
Oh yeah, they're so yummy. Okay, but I did something to these gummy bears yesterday, and I put some of them in different kinds of water. I put some in distilled water, I put some in tap water, and I put some in salt water. I'm gonna pull out one from the salt water container real quick, and I'm just gonna put it next to one of these so you can compare. So, what do you notice first?
It shrunk.
It shrunk! Oh, that poor little gummy. It shrunk a
It
little.
looks like blue.
Oh, it kind of changed color a little bit too. All right, I'm gonna pull one out of the tap water, see if I can get it without hurting the gummy. What?
It's
What?
huge.
What's going on with that gummy? I'll even turn him around so he's with his friend. Oh my gosh. Okay, and if I'm careful, I can get one out of here with the distilled water. I broke his little head. I broke his little head. Look at how huge that is. That's without his head.
Distilled water is bigger.
Okay, that's a really good observation. Now, if I carefully put this on my scale. Now, when I measured these at the beginning, they weigh about 2.3 grams. This one weighs 13.678. It's moving around a lot because it's jiggling. It has gained a lot of weight, hasn't it?